This MCQ is from NEST 2020, Shift 1, question number 11. An element of atomic number Z is in the ionized hydrogenic ground state. The largest wavelength that can convert it to a fully ionized state is 3.65 nanometers. Select the correct statement or statements. 1 nanometer is 10 raised to negative 9 meter, and take the ionization energy of the hydrogen atom to be 13.60 electron volts. Okay, and the options are its potential energy is 680 electron volts, atomic number is 5, its kinetic energy is 340 electron volts, its Bohr radius is 0.1 nanometers. Okay, so we are given an element. Okay, we are given an element, atomic number is to be found out, could be 5. Now let us try to understand what is meant by hydrogenic ground state. Okay, see, hydrogenic ground state refers to a state where we have only one electron. Okay, so when it comes to helium, okay, helium has how many electrons? 2 electrons. So He plus is hydrogenic state. Lithium has how many electrons? 3, right? So Li2 plus, that is the hydrogenic ground state. Then I think beryllium is the next element with atomic number 4. So beryllium with 3 electrons removed, that is in the hydrogenic ground state. Okay, so only one s1 electron is there. Okay, one s1 electron is there. So have you understood this part?
Yes, sir.
Okay. Okay, now let's go to the next part. They say the largest wavelength that can convert it to a fully ionized state. Now what is meant by fully ionized state? Okay, fully ionized state refers to a state where only the nucleus is there, all the electrons are gone. Okay, so no electrons, right? We know that what exactly it means. It's basically a state where no electron is bound to the nucleus. Okay, fully ionized state, and they are saying largest wavelength. Now if it is lambda max, that basically means nu min, least frequency. That basically also means that the energy that we are giving to the electron is the minimum energy. Okay, fine. Now they are saying take the ionization energy of the hydrogen atom to be 13.60 electron volt. Okay, so what we will do is we will first find E min, and from E min we can find potential energy, kinetic energy, hopefully Z, and then the Bohr's radius. Okay, so let us first start with the fact that lambda max is 3.65 into 10 raised to negative 9 meters. Okay, and this is the formula for energy, En. Okay, let us take that formula and let us apply it to our case. Okay, now look, this is lambda max. Okay, so from lambda max can we how can we connect it to nu min? Look, lambda is equal to C nu, correct? Lambda is equal to C nu. Okay, so what can we say? Yes. Oh yeah, sorry, C by nu. Lambda nu is equal to C. So nu is equal to C by lambda, and we are required to multiply it by h so that we can find the energy h nu. H nu is equal to hc by lambda. Okay, all right. Now what will be the ionization energy? ionization energy would be, say, E ionization. It would be positive of this, right? This is the energy that the electron possesses in its ground state. Okay, so it will be z squared e raised to 4 me upon 8. There is no need to write now that n squared because that has now become infinity, so only n equal to 1 will remain. H squared epsilon naught squared. Now the good news is that they have already given us the ionization energy of hydrogen atom. Okay, which means this part is already ready with us. Okay, so what can I say? Therefore 6.626 into 10 raised to negative 34 into 3 into 10 raised to 8 upon 3.65 into 10 raised to negative 9, that is Hc by lambda, that is ionization energy, equal to z squared into, now that is 13.6, agreed, but that is in the electron volts unit, so we must multiply it by 1.6 into 10 raised to negative 9. Okay, from this we can find z squared, take the root. If we get it as 5 or close to 5, then option B will become correct, otherwise it will be incorrect. Okay, so let's go to that. Okay, 6.626 into 3 upon 3.65, okay, into 13.6 into 1.6. Okay, so this basically gives me what? This basically gives me the digits that our square of atomic number has 0.25 into, now that might be the case of atomic number 5 because square root of this is 0.5, but we never know. Now we need to consider the powers of 10. Okay, so negative 34 plus 8 plus 9, that negative 9, when it goes to the numerator it becomes plus 9. And how about this negative 19? That should also be added to this. That's 2. Okay, that is 2. Okay, that is 2. Which means this must be multiplied by 10 squared, and that is z squared. Okay, so 10 squared into 0.25 is 0.25 into 100, which is 25. So z squared is 25, which means z has become 5. Now if z is equal to 5, can we say that the atomic number is 5? Yes, so B is correct. Okay, raise your hands if you understood this part. B is correct. Okay, B is correct. Now let us go for options A and C. Let us find out the kinetic and the potential energies of this particular atomic species. Okay, now what have we seen there? We have seen that En is equal to negative z squared into that. Okay, so let us find out E1 now because it is in the ground state. Okay, E1 is equal to negative 13.6. Okay, negative 13.6 into z squared into what? Z squared. Okay, so let's find it out. Negative 13.6 into 25. Okay, negative 13.6 into 25, that is negative 340. Now we know that kinetic energy, okay, kinetic energy is mod of the total energy. Okay, so kinetic energy is 340 electron volts. Is it right? Yes. Okay, its kinetic energy is 340 electron volts. That is right. Now how about its potential energy? Potential energy U is negative and it is 2 times the total energy. So see now, potential energy's sign is important. We cannot just say that it is 640 volts, electron volts. That's wrong. Which means, can we say that option A is right? Magnitude wise it is right, but although potential energy is a scalar quantity, just like we cannot say that if my temperature is negative 3 degrees Celsius, I cannot say that it's 3. Similarly, I cannot say that my potential energy is 630 electron volts if its actual value is negative 640. Negative 680. Sorry, negative 680. 2 times, so that will be 4. Okay, so although the digits are the same, it's not the right option because the sign doesn't exist there. Okay, negative sign is not there, so B is not right. Okay, B is not. Now, can we find out Bohr radius? Yes, we can find out the Bohr radius, and for that we have to make use of this particular expression. Okay, this particular expression. Okay, now does anyone remember what is the Bohr radius for our hydrogen atom? Does anyone remember that? R1H, that is 0.053 nanometers. Correct? 0.053 nanometers. Now if you know that, it will save your time in calculating all this stuff. Which stuff? Epsilon naught into h squared upon pi e squared me. Okay, that is actually 0.053. Okay, and n is equal to 1 for Bohr radius, right? Ground state. And z here for hydrogen it is 1, but for this particular atomic species z is equal to 5. Okay, and of course n is equal to 1 being ground state. Okay, so what can we write? 0.053 divided by 5. Change the option. 0.0106 is there and this is 0.2. Okay, so D is not right.